The next, body centered cube. In body centered cube, spheres present are at corners and body centers. Spheres are present at corners and body center. Remember that. So, spheres touch each other only this sphere number 1 and 2. They don't touch each other. Remember that. Sphere number 2 doesn't touches 3. Sphere number 3 and 4 also don't touch each other, but 1, 4 and 5 touch each other. So that sphere number 1 is shown here, sphere number 3 is shown here, sphere number 5 is shown here. So if you know this value is R, this value is R, this value is also R, and this value is also R. So from here to here, what is that value known as? Here to here, the value is known as 4R. So value is known as 4R, remember. Now, right, if you use geometry, then this body diagonal has a value of a root 3. So length of a body diagonal is a root 3, and we have realized in this case body diagonal is 4R, and 4R is equal to a root 3. That is the relation between a body diagonal, so not body diagonal, the relation between radius of the sphere and edge length. If you go back, remember sphere number 1, 5 and 4 touch each other. So this value from here to here it is R, from here to here it is 2R, from here to here it is R. Total value in this case is 4R. So 4R is body diagonal, and body diagonal value is a root 3. Rank for BCC. Rank for BCC is, there are 8 spheres at 8 corners, and each corner has a contribution of what? 1/8. One sphere is present at body center, its contribution is 1. So if you add all, rank is 2. So if you want to say, there are, we say 9 lattice points. Why 9 lattice points? 9 lattice points because there are 8 corners and 1 body center. So 9 lattice points, but rank is 2. So effective number of spheres are 2. So what is the packing fraction for BCC? Right, you remember this formula? Z multiplied by 4 by 3 pi r cube upon a cube is a packing fraction. What is the value of Z for BCC? 2. What is the relation between A and R? You remember previous slide, 4R is equal to A root 3. Therefore, A is equal to 4R by root 3. Put the value of A, put the value of Z, you come to know pi multiplied by root 3 divided by 8. If you put the value of pi as 3.14, root 3 as 1.73 divided by 8, and if you solve that algebra, that is 0.68. That means 68% space in BCC is occupied and remaining 32% is empty. This is what we understand. So if you remember SCC, right, space occupied was 52% and BCC space occupied now is 68%. That means BCC is more packed. So we say BCC solids will be more dense. So all those metals who will be present as BCC and all those metals which will be present as SCC in solid state, metals with BCC will be more denser than those metals with SCC type of arrangements.